Hey everyone. Okay, continuing on with the notes, we're going to do some application problems having to do with quadratic functions. So the idea behind this is we're dealing with maximum and minimum problems. In either case, we're always going to start out the same way, which is finding that minimum or maximum point. And it's the same formula for either one you have. It's x equals negative b over 2a. Remember, we're talking about the general form. F of x is equal to ax squared plus bx plus c. And remember that if a is positive, that means that my parabola opens up, so my minimum occurs at negative b over 2a. If a is negative, my parabola opens down, so a maximum occurs at that negative b over 2a. But in either case, we're still going to start with finding negative b over 2a. So let's go through a few different examples. The first example here is talking about an archer. Okay, so an archer's arrow follows a parabolic path. So think about here, okay, and you all know that I can't draw, so here's my little archer dude. Right, here's his, you know I can't draw. Here's his little bow, oh, I did that backwards. Here's his little bow and arrow, right? I can't even draw a bow and arrow, but I think you guys get the general idea, right? So here's his little bow, and he launches his arrow. So it goes up like this, and then it comes back down, okay? So that is the parabolic path that they're talking about. So it says the height of the arrow can be modeled by that given equation where x is the arrow's horizontal distance in feet, okay? So part A says what is the maximum height of the arrow and how far from its release does this occur? Okay, so basically we're finding this distance x and this height of y, or f of x. You can think of it that way. Okay, so the first thing I want to do is find x equals negative b over 2a. And so we're just going to plug those values in from our formula. So we've got negative 2 over 2 times negative 0.005. And if you do that out in your calculator, you end up with 200 feet. Okay, so that's how far from its release does it occur. So that x value, so this distance here is 200 feet, but now I have to find that maximum height. So now I'm going to find f of 200. Basically, I'm plugging 200 back into my original equation. So 200 squared plus 2 times 200 plus 5. And if you do that out, you end up with 404 feet. Okay? 404 feet. So that's part A. Part B says find the horizontal distance the arrow travels before it hits the ground. So I'm trying to find from here all the way out to here. And so some people say, well, don't you just double that, because if halfway over, right, that's right at the middle, then you have just another 200 to go. But you have to take into account that this isn't launched from the ground. So you have to figure it out in a more mathematical way. And the idea is this. When it hits the ground, its height is 0, right? When it hits the ground, its height is 0. So what I'm actually going to do is set my original function plus 2x plus 5. I'm going to set that equal to 0. And I'm going to go ahead and solve that. I'm not going to try and factor that. That would be crazy. If I just go ahead and do the quadratic formula, I think that's going to make life a lot easier. So negative 2 plus or minus 2 squared minus 4 times a times c, all of that over 2a. And I'm not going to go through the whole calculation. But you end up with two different answers. The first answer comes out to be like negative, you get two values here. You get negative 2 points, I forget what it was, 2.48 something. And your other answer comes out to be 402.484, something like that. So think about this for a second. If this was your zero value, right, this would keep going back. So this distance between where it was launched and here and where it would have hit the ground would be 2.484, right? But it's negative because if you think of this as your 0 point, you're going back 2.484 feet. So the distance from here to the end is 400. So this last point is 402.484. So that's really what's going on there. So let me say that one more time. This arrow isn't being launched from the ground. He's not laying on the ground launching the arrow. He's launching it right from here. So it's not a full parabola. So it goes 200 feet from where he launched it, but then another 200 feet would be the distance it goes, but not from where the parabola would start on the ground. So you can't just assume that the distance is 400. You have to go back to the original equation, set it equal to 0, because that'll give you your x value when your height is 0. So think of it almost as you're finding the roots, right? So if this is your axis, your parabola is really doing this, and you're finding this value and this value. Okay, that's in essence what you're actually doing. Obviously, we can't have a negative distance, so our answer is 402.4. It said to round to the nearest foot, so our answer is 402 feet. So again, all we're doing in the first part is finding negative b over 2a, and then plugging that value in to find the maximum height and to find the distance at the maximum height. And in part B, we're finding the horizontal distance, and to do that, all we have to do is set our function equal to 0 and solve for x. Okay, in the next one, it says, among all pairs of numbers whose sum is 40, find a pair whose product is as large as possible. So what I want to do is, I want to create my equation first. In this case, they didn't give us an equation, so we have to figure out what it is, and then we can do our negative b over 2a. I know that product, right? I'm just going to be multiplying two numbers together, x and y. I also have some other really valuable information here. The sum of those numbers is 40, so if I have x plus y is equal to 40, I know that y is going to be 40 minus x. So I can substitute that in, right? So I can say my product, p of x, is going to equal x times 40 minus x. And so if I multiply that out, I end up with 40x minus x squared as my function. Okay, as my function. From there, then, that's going to allow me to go ahead and do x equals negative b over 2a to figure out the pair of numbers that gets me the largest possible product. Okay, so I have negative b, so that would be negative 40. So you have to be careful because these are in reverse order. Over 2 times negative 1. So it would be negative 40 over negative 2, so that would give me 20. So when x is 20, that number is one of the numbers that's going to make my product as large as possible. If I plug that in to my function, then I can figure out what that product is, right? So if I go ahead and plug in and I find P of 20, I end up with 40 times 20 minus 20 squared, which would give me 800 minus 400, which would give me 400. So 400 is the largest possible product, but it says find a pair whose product is as large as possible also. So this is part B. What is the maximum product? It's 400. But my pair of numbers, if one of them is 20, that means the other one has to be 20. So if we say x is 20 and y is 20, that's my pair of numbers. That gives me my largest possible product. Okay, so I just took a product of two numbers. One number is x, the other one is y. And the sum of them was x plus y equals 40. Substituted that in. And then I did my negative b over 2a. Okay, very similar to the last problem, right? We need to maximize our area. We have 100 yards of fencing to enclose a rectangular area. So again, if I call this x and y, I know that area is going to be x times y. I also know that my perimeter, 2x plus 2y, has to equal 100. Okay, because I have 100 yards of fencing. And so again, I can solve this equation for y so that I only have one variable in my function. So I have a of x then is equal to x times 50 minus x, which gives me 50x minus x squared. So that's my function. Now I can go ahead and find the dimensions to maximize the area. So now I can do negative b over 2a, which would give me negative 50 over 2 times negative 2, so that would give me negative 50 over negative 4, which would then give me, how did I get to, oh, sorry folks, that isn't negative 4, it's just negative 1. I'm getting ahead of myself here. Negative 1, so that makes that negative 2, and that would make that 25. Okay, so x is going to be 25, and then I can plug that back in. So if x is 25, then I also know that y will be 25. So I have x is 25, y is 25, and when I find the area and I multiply those together, I end up with 625 feet squared as my maximum area. Okay, again, I could have just plugged 25 back into my function a of x, and I also would have gotten 625. Or you can just multiply your dimensions together. Okay, so that's how you're going to approach those problems. Hopefully that helped going through those. The problems on the homework are very similar to this. That's about it. So I'll see you guys next time. Thanks, everybody. Bye-bye.